Hello, 6th grade, and here is your Unit 2 mid-module review. All right, so Jasmine here, she's having a party. She's got snacks and activities for her guests. At one table, 5 people are sharing 3/4 of a pizza. So what equal size portion of the whole pizza will each of the 5 people receive? So first, it's asking us to use a model to represent the quotient. So we're going to draw our pizza here. It's going to be a square pizza. And we're going to separate it into the quarters. And then we have our 5 people. So here's person 1, 2, 3, 4, 5. And then this is how much pizza we have left. So one person is going to get 3 out of 20. Okay, so write a number sentence to represent the situation. So our number sentence is going to be our equation simply. So we have 3/4 of this pizza divided by 5 people. We can't divide fractions, so we're going to do 3/4. This is the same as 5/1. So we're going to multiply 1/5. 3 times 1 is 3. 4 times 5 is 20. And then explain your reasoning. So essentially that, because you have 3/4 of a pizza and you're dividing it amongst 5 people, so I have to have the 3/4 of the pizza divided among 5 people. Okay, so then if 3/4 of the pizza provides 12 pieces, how many pizzas were in the pizza when it was full? So we have 3/4 of the pizza, and now we're actually dividing it. We're taking that 12 and we're dividing it by the 3/4, because here we have our pizza. We're shading 3/4 of it, and we know that this is 12. So we're doing 12 divided by 3/4. I'm going to move this over here. So that's going to become 12/1 divided by 4/3. So 12 times 4 is 48. Over 3. And if I simplify that, if I do 48 divided by 3, this becomes 1, 3, 1, 8, 6. Is 16. So there's 16 pieces total, and each of these is 4. All right, so Jasmine needs to create invitations for the party. She has 3/4 of an hour to make the invitations. If it takes her 1/12 of an hour to make each card, how many invitations can Jasmine create? Okay, so we're going to use a number line to represent the quotient. One second. Okay, so we're going to divide these up into 12ths, or represent 12ths. So I have 1/12, 2/12, 3/12. Okay, so we need to figure out where our fourths are. So this is the same as 1/6. This is going to be 1/4, 1/3, 1/2, or 2/4. We'll represent that as 2/4. is 2/3 and 3/4. So all I did was I changed those fractions a little bit to represent what we're doing. Okay, so each of these represents an invitation, and this spot right here represents how much time she has. So we're gonna make 1, 2, 3, 4, 5, 6, 7, 8, 9. She's able to make 9 invitations. Okay, so now we're drawing a model to represent the quotient. So first we're dividing it up into our quarter hours, or our 15 minutes. And then we're going to divide this up into our 12ths. So as you see, there are 3 12ths in this quarter hour. Excuse me. So these dark lines are our 4th. And the dotted lines are our 12ths. Okay, so then we're still shading in, we're going to be shading in this 3/4 of an hour. So we still have 1, 2, 3, 4, 5, 6, 7, 8, 9. We still have 9 that we're representing. Okay, and then compute the quotient without models. So you're doing the same thing. So we're taking 3/4, dividing it by 1/12. Since we can't divide fractions, we need to shift that. So we have 3/4 multiplied by the reciprocal. 3 times 12 is 36. 4 times 1 is 4. That simplifies to 9. So all of these answers, we have the same value of 9. All right. Jasmine is serving ice cream with the birthday cake for her party. She has purchased 19.5 pints of ice cream. She will serve 3/4 of a pint to each guest. How many guests can be served? So we're taking what we have, 19.5, and we're dividing it by 3/4. This needs to become an improper fraction, so we're going to multiply and add. 19 times 2 is 38, plus 1 is 39, so I have 39/2. Divided by 3/4. Still can't divide fractions, so that becomes 39/2 times 4/3. And I'm just going to grab my calculator quick. 39 times 4 is 156. Divided by 6. And that simplifies to 26. So she can serve 26 people. Will there be any ice cream left over? Well, that depends on how much she has. If she has 26 people, she will not. There's no extras. If she's inviting more people, then she won't have enough. If she has less, then there's definitely going to be enough. Okay, so this depends on how many people she's inviting. If she has 26 people at her party, she has exactly enough. All right. Frank Lloyd Wright Middle School held a track and field event during the school year. Michael took part in a 4-person shot put team. Shot put is a track and field event where athletes throw a heavy sphere called a shot as far as possible. To determine a team score, the distance of all team members are added. The team with the greatest score wins first place. The current winnings team final score at the shot put is 52.08 feet. Michael's teammates threw the shot put the following distances: 12.26 feet, 12.82 feet, and 13.75 feet. Exactly how many feet will Michael need to throw the shot put in order to tie the current first place score? All right, so we have 52.08, and then we're just going to be subtracting out these distances. So I'm going to subtract 12.26, 12.82, and 13.75. Excuse me. All right, so I have 8 minus 6 is 2, minus 2 is 0, 5. We're going to have to borrow from all the way over here. 18 minus 6 is 12, minus 2 is 10, 5 is 5. 9 minus 2 is 7, minus 8. I'm going to pull another one. 15. Yep. I'm going to make that a 0, and then a 9. Okay, 19 minus 2 is 17. Minus 7 is 10. Minus 8 is 2. I'm going to have to borrow from over here. 10 minus 2 is 8, minus 2 is 6, minus 3 is 3. 4 minus 1 is 3, 2, 1. Okay, since we're subtracting, we need to line up our decimals. Decimals don't move, so this ends up being 13.25 feet to tie. All right. Number 5, the sand pit for the long jump has a width of 2.75 meters and a length of 9.54 meters. Just in case it rains, the principal wants to cover the sand pit with a piece of plastic the night before the event. How many square meters of plastic will the principal need to cover the sand pit? So here we're talking about area because we have square meters. So we're going to do 9.54 times 2.75. And we're going to multiply this through. 5 times 4 is 20. 5 times 5 is 25, plus 2 is 27. 5 times 9 is 45, 47. Okay, I'm going to move my 0 because I moved over. 7 times 4 is 48. No, 28, sorry, 28. 7 times 5 is 35, 36, 37. 63, 66. I'm moving over 2 more decimal places. 2 times 4 is 8. 2 times 5 is 10. 2 times 9 is 18, 19. So we have 0, 15, 15, 22, 23, 12, 16, and 2. So this is the number you get when you add all of those up. And then we're going to count the numbers behind your decimal. So I have 1, 2, 3, 4. So now I'm going to do 1, 2, 3, 4. So we will have roughly 26.235 meters. And if you want to check that on the calculator, you can. So we have 9.54 times 2.75, 26.235. Same value. All right, last question. The chess club is selling drinks during the track and field event. The club purchases water, juice boxes, and pouches of lemonade for the event. They spent $138.52 on juice boxes, $75 on lemonade. The club purchased 3 cases of water. Each case of water costs $6.80. What is the total cost of the drinks? So we have a total here and a total here. We need to figure out what this total is. So we're going to do $6.80 times 3. 3 times 0 is 0. 3 times 8 is 24. 3 times 6 is 18, 19, 20. So they spent $20.40 on the water. So now we're going to add those up. So I have 138.52 plus 75 plus 20.40. Again, we're adding these, so we're going to line up those decimal points. That's a 2, 9, 13, 11, 13. And then our decimal point comes along too. So we spent $233.92 on all of these drinks. All right, so that is your review. Please reach out if you have any questions, and good luck tomorrow.